10:31. So good morning, everybody. Wow, a bit of a full booth here. So I hope you can hear me. Just the first time that we've delivered this morning, so just getting used to the acoustics. So my name is Karl Ritz. I'm a professor of soil biology at Cranfield University, and my task this morning is to change your perspective of what lies beneath. I'm going to tell you about soils, and particularly the structure of the talk is going to be in relation to give you some insights into what soil is, what soil does, because as a scientist I'm interested in how soil works and functions, so we'll give you some details on that. Inevitably, as I describe things, I'll be giving you some perspectives on contemporary research that's going on in the area, and then I want to touch a little bit on some training and learning opportunities. I'm going to be talking about how things work rather than nuances in managing your soil system in terms of potatoes especially, for a reason I'll come back to towards the end. But the first thing I want to do is just give you a feel for scale, of course, because there are planetary matters we need to consider. Your focus maybe is on the potato field, but remember that our planet is called Earth for a reason, and that is because the landmass is comprised of soil, or what we call Earth. Now, you might want to try that in different languages. It certainly works in many cases, the exception being United States, where sometimes it's called Deut. What is soil? Well, first and foremost, from your perspective, it's a resource, and of course it's your fundamental business resource. From a more scientific perspective, I like to think about soil as a structured, porous medium. More on that in a minute. The other thing is it's adaptive, it changes, it's dynamic, it changes over time. Soil is not an inert material, and there are special reasons for that. The principal one being the life that occurs below ground, and that's going to be one of the main themes of my talk, not least because it's one of my main areas of research. So soil is also then a habitat, it's where things live. The other thing you need to understand is that soils function, soils do things. Why is this not... Yeah. Soils function, they do things, and in fact they do a lot more than just produce food, which is in the middle of this slide here. This is giving the whole frame for what we call ecosystem goods and services, which describes the panoply of things that soils do, and they range across supporting things, provisioning things, regulating, and cultural as well. So soils do a wide variety of jobs, both for the ecosystem and then for our societies. As to what soil actually is, well, it's extraordinarily complex, and we haven't got time this morning to go into all the details of that, but essentially it's made up of these 6 sorts of things. Mineral material, solid stuff; organic matter, solid stuff, a little bit springy; life, which I'll tell you more about in a minute; and then moving around within that you have gases and water and things dissolved, and things, little bits and pieces, colloids, tiny things that are hanging around in that water. And the critical thing about the three things on your right is that these are all involved in movement. So if gas and water is moving through the system, that starts to allow the functions and dynamics to occur. And of course, many organisms are also moving down there. So a few perspectives on soil then. I'm going to give you take you through some different scales of soils as systems. This one is a scale that you're most familiar with. It's a potato field, and so far so good. If you look at the surface of that soil, it's still familiar. This is the scale that we're used to looking at soils as humans. This is what our eyes will see, so it looks pretty soily. There's some straw at the top there. Things start to change, perspectives alter when you magnify that by another factor of 10. And now the story gets a bit more intriguing. Now we can see some plant roots, again, so far so familiar, but also pores are starting to appear. So you can start to see the soil is porous there. There are holes. There's also those thin threads connecting those roots together. They are fungal hyphae. Now you can't see those with your naked eye. They're microbial. The other issue with soil is if you dig it up and try and look at it as a scientist, it falls apart. And we know that soils function by virtue of their being held in a particular way in space. So one of the ways we can deal with that, if we want to look deeper into the system, is to embed the soil in a plastic resin and take slices of it and sections of it, so we can look at how the soil particles are arranged in space in the normal circumstance. And now the perspective starts to change a great deal. Now you can start to see how complicated it is structurally. There's sand grains there, there's pores, there's a bit of coal and so forth. Very different perspective and extraordinarily complex. Now, the structure of the soil, how it's put together in space, is absolutely fundamental to how soils function. And what it's all about is this pore network. As I said, soils are porous. And what's intriguing about soils is that there are pores, there are holes in the soil at all spatial scales, from centimetres right down to a thousandths of millimetres. Whatever scale you look at soil structure, you see these sorts of pores. And the reason that this is so important to how soil then functions is that it relates to it provides the holes in which roots are going to be growing. It affects how the soils hold water. Very important relationship between how big the pore is and how water is held in that. It relates to things like compaction. A compacted soil will have less space in it and therefore less room for manoeuvre for the gas and the water and the organisms. How strong the soil is will affect whether it erodes or not. So it's not just about the pores, it's how that pore network is stable and so forth. And it also leads to the nature of the habitat. This is the living space. This is the space in which soil organisms and soil biota are resident. So I want to just touch a little bit on life below ground, because you may be less familiar with it, not least because it's microbial. The majority of life cannot be seen with the naked eye. So what I've done is thinking about this. Here's a handful of arable soil, about 200 grams, and in there'll be about half a gram of living material, or fresh meat, if you like. If you do a back of an envelope calculation to scale what that means, if you could make all that life come out of the soil in a big wobbly heap, say, rather remarkably, it relates to about 5 tonnes per hectare, or the equivalent of 100 sheep. And in grassland systems, 20 times that. So there is always as much life or biomass above ground as below ground. Now, as well as this huge biomass, there's also a great diversity. So there are hundreds of trillions of bacteria in that handful of soil, and kilometres of fungal hyphae. All these different ranges of organisms, as well as a huge biodiversity, tens of thousands of species of bacteria in a typical soil. So biodiversity below ground is always considerably greater than that above ground. The question then is, well, what do these organisms get up to? And the analogy I like to use for this is I describe that soil biomass as the biological engine of the earth, because it's driving so many of all those key processes we saw in the earlier slide. This then leads to the issue as to why is biodiversity important. Everyone says, oh, biodiversity is important. Here's the reason why. And it's because it relates essentially to all those organisms are a form of biological toolbox. And so it's straightforward if you think about it. The more diverse the system is, the more tools there are for the job to do these different functions that we require of the system. Functions we require both now, at the present, but crucially also for the future. So what biodiversity does is it underpins potential for future adaptation and resilience for changing environments. I've mentioned that soils do all these different sorts of jobs. Just going to give you an example of one that you might not have thought about, and that is that the soil biota is involved in creating this soil structure that I've explained is so important. How do we relate that? Well, here's a way of capturing it. Essentially, it's a bit like a typical morning at a kindergarten, because what's going on is a whole load of moving, gluing, sewing, painting and eating. The way this works is the soil is moved, for example, by the larger organisms such as worms, so worm burrows and worm casts, you'll appreciate, make structure. A lot of microbial life is sticky, so it glues soil together. There is sewing by plant roots and these fungal hyphae, these meshing networks. And also the microbes produce all sorts of compounds that coat the surfaces of the soil pores and make them more or less resistant to water penetration. So a little snapshot there of an example of a soil biological function that provides in relation to creating this structure. Really important feature as well, as I've talked about the structure below ground, it's also there's important matters relating to the surface of the soil. This is the critical interface where when water arrives, whether it enters the soil or runs off and maybe takes soil with it in eroding terms. This is one of my key current research interests in terms of looking at how the surface structure of the soil is affected by microbial growth and so forth. And on the other side, here we have an example of a X-ray computed tomography. So I'm using X-ray CET to look at structure. You can see that ceiling at the top there. And I think that the biology will have a big effect to play on whether that ceiling prevails or not. Something else I wanted to give you a feel for about this business of the biological engine is how does it actually work? Again, not time to go into details, but this is the essence of it. It's all about food webs. And what happens essentially in a food web is little stuff eats smaller stuff, and bigger stuff eats that smaller stuff. So there's a transmission of material from the plants to the soil organic matter. The microbes eat that, then the animals eat them, and the bigger animals eat them. And each time there's a movement or a transmission of material from one organism to the other, energy is transferred and work is done. Okay, so if these fungi are growing, they're creating that soil structure. They need the energy to do that. So this leads to the crucial concept of carbon essentially being the fuel for this soil engine. And if you like, you can also think about carbon as being the currency then for the soil economy. This is why soil scientists get so hung up about organic matter, because essentially that's carbon. And what that does is it leads to providing the fuel to drive the engine, whether it's in terms of soil structure or nutrient cycling or whatever else. So this takes us on to the frames and the concepts of another popular phrase, soil health. My single sentence definition of what a healthy soil is, in general terms, is one that's constituted and managed in such a way as to be fit for purpose. So it depends what you want the soil to do. And therefore there could be a subtle difference whether you're a forester or a potato grower or you're wanting to train troops on the ground or whatever else. So again, it comes back to there's no simple answer to these matters. You've got to think about soil as multifunctional and also think about it beyond the frame of just growing potatoes this year, but in the wider sense of the rotation or the larger environmental context. Again, one way just to capture all this is to think about the 5 key components in what constitutes and underpins what makes soil function and therefore relate to health. And here's a set of 5 that I think are of primary importance. The trick and the interesting bit as a scientist and your challenge as managers, of course, is that these are all connected. And again, this is the issue. Think about soils as systems and connected components that interact with each other. So if you fiddle around with one, the other features and components are going to be affected. Of course, there'll be something else in there. It's not just 5, there are other things. So I put the etc. just to calm questions down after these sorts of talks. You missed pH, whatever. The other thing is then this can lead to concepts of how we go to measure and assess soil health. Where can we stick the stethoscope in the system in order to understand whether the soil's in the state we want it to be? And again, one of my research interests is using the soil biota or the biology to tell us about that. And I have some ideas about this is a good point in which to stick the stethoscope to understand the state of the system. Just a little bit of an aside now from the soil system and stuff. PC asked me to mention, again, just to remind you or set the frame for some legislative issues relating to soil management. So here are things you're probably all more or less familiar with, and at the bottom there is the potential looming soil framework. Really what I want to say about this is that the legislation is there in a sense to protect the soil, and rather than worrying about that, if you worry about managing your soil fundamentally from the sorts of perspectives I'm leading you to, then this stuff won't really be an issue. The other thing I'd like to mention again is just to give you some up-to-date stuff in terms of the kind of work that the AHDB are funding in relation to soils. They have a platform working within the soils framework. Here's a number of grants that they're funding in these different regions. A lot of the focus, I'm pleased to say, is in relation to sorting out indicators of physical conditions and, again, concepts around resistance and resilience of the physical structure of the soil. So the emphasis there is looking very good. And they're also now funding, so PC is both funding, PC and HDCA, but they have a joint project that's connecting these two together. And again, members of staff from the HDB would be pleased to tell you about those sorts of aspects if you like. Personally, I'm involved in the bottom left one there in relation to organic matter or fueling the engine as well, and happy to talk about that if you wish. So the reason I've really focused on fundamentally how soils work and are constituted is because I haven't really got time to go through all the nuances of management and so forth. But I would recommend that there is an excellent guidebook from the Potato Council on soil management for potatoes, updated 2013. A lot of common sense in here, a little bit on soil biology, mainly chemistry and physics and structure and so forth. So perhaps that's something I need to think about for the future. But I'd really recommend you have a look at that to inform you about these management aspects. And a couple of other online resources that I'm affiliated to. The Soils Reporter will give you soils data geographically, because my institution houses the National Soil Inventory, and SoilNet is an online educational resource primarily aimed at schools, but again there's an awful lot of easily accessible stuff on there to tell you about sort of encyclopedia of soils. The other thing I just need to feature a bit is really training and learning opportunities, because again soils are complicated things. There's a lot to learn about there, and to raise the Advanced Agri-Food Training Partnership that the BBSSC are running, which is providing training and workshops across the entire sector. It's well funded. There are 100% bursaries available. If you don't know about this, there's the website. I have some leaflets, and there's also some stuff outside on this, so well worth a look. In terms of this, some things to highlight in relation to potatoes is a looming course for potato production management, so highly focused and specialised on your area. And there are also a suite of special one-day CPD courses on soils that I'm actually responsible for coordinating. And these 6 cover the breadth of things I've just touched upon today. So if you're interested in picking up more details on that, I can have a look at the website. This week will be running in the spring and in the future. So that was the commercial break. I'd like to come back and finish really with just how can I summarise everything I've said so far? How can we capture all this? And the phrase I like to use is get away from soil structure, which is a sort of basic physical connotation, and start to use the phrase soil architecture. And this is carefully chosen because what architecture is all about is it's the relationship between living things in the way that they are organised spatially. And I think the key concept above all else to remember then is that soil is a living system. You're not aware of that because you can't see this life. It's a living system, and it's founded on an appropriate spatial configuration, just like our cities. Get it wrong, get the structure right, get the structure wrong, the city can collapse and fall apart. And it's also then about communities as well. So it's all about having appropriate community structures living within this pore network, if you like, an inner space rather than outer space, that's inner space below your feet. And this, if you just start thinking about soils in those sorts of terms, when you're managing them, then I think that soil health will inevitably arise and result from that. So manage your soils accordingly. Think about them as living systems as opposed to just some inert matrix into which you're putting all your inputs and making your crops grow. And I hope I've given you the perspective then that actually there's a lot more to soil than meets the eye.